All right, let's give it a try. I'm going to show you how to use Maple. So after you open the file, you will see something like this. Now, Maple is command line driven, so it's not really something that programming over here. And if you see this greater than sign, that's the math one. So you see over here math mode, and it can also type things in text mode, but let's not do that. Just make sure you're in math mode. Okay, so math mode. And you see each line is finished either by a colon or semicolon. Colon means no returns. Semicolon means yes returns. And we will show you the results. Okay, I'll show you that. One thing you need to do is that at the beginning, you always want to load certain packages. And here, I just copied these things from somewhere. So this is called plot setup maplet. And then with plots, that means these two packages are loaded. But you need to use your cursor, move your cursor behind these two and hit the enter button. Okay. And then you see your cursor move to the second line. Now let's just try to see what happens if I change this colon to semicolon. Yeah, and then you will see if I hit enter, it will give you a list of commands within this package plots. Okay. And we don't really need to use many of them, so we don't want to see them. Okay. The most useful command is called plot3d for our multivariable calculus. And here, I was trying to graph a sphere of radius 2. But you remember there is a northern hemisphere and a southern hemisphere. So I need to use negative square root and positive square root. And I hit then enter again after this semicolon. It's not very good. The reason is that at the edge, we have so-called derivative infinity, and it looks like some kind of scary shock math, right? And then you can move your cursor around, try to see what it is. Later on, we're going to try other examples. Okay, so this is the basic 3D visualization. And you can click this one over here, get rid of it. And look at this one. This is the concept we did in the first chapter 14, I think, the contour plot. Okay, it's this package is made by a Canadian company. That's why I call it Maple. Contour plot. This is a two-variable function. So we are looking at these curves called sine x, y equal to c, and you will see these are the lines like that. Okay. Now you may say, "Oh, I don't see periods." That's because we are looking at only the lines over here, and you do see some kind of bands going to far places, right? And look at how we enter these bounds over here. So we said x is between -3 and +3, and y is between -3 and +3. You can actually change this 13 and 13. The best way to learn to do these things is just to make small modifications of these examples. That way you can actually do things better. Okay, so here, and let's see, oh, what we have over here. And you will see periodicity, right? Amazing. Okay, so if you can actually grab it and make it bigger, not much bigger, but you can see. All right, so these are the contour plots. And another useful one is called Implicit Plot 3D. So here you can type in equations And you can type in multiple equations, this one over here. And there are many, many options. You can say style equal to surface, color equal to Niagara, azure. I don't know what kind of color it is, but we can take a look. Enter. Okay, so it's kind of deep bluish. Okay, so this is the graph of this very complicated equation, x cubed plus y squared minus z cubed equal to 16. Okay, and you can change these bounds over here. The next one over here, I put two surfaces together. We had this kind of thing in multivariable integration. And this time I'm going to use red, and then you will see we have a cylinder and intersect with a plane, right? And now you can try to see what kind of things you have over here, right? You can put multiple equations in a pair of braces and to graph them. Okay. Now, just in case you don't know how to use these commands, and then you can put a question mark in front of it, and then it will bring you to the Maple online help menu and say, I want to know more about implicit plot 3D. Put a question mark in the front, and the command follows that, and then hit enter. And then here, actually, you're in another window, and then you will see. And this is how I learned through these things, because there are explanations, especially if you pull it down, we have examples. Yeah, you see over here the examples. You can just copy examples over there and make changes, and you can do so many different things over there. Okay, so this is how I use the help menu. So I was trying to visualize a vector field, and then I need to use another package called with vector calculus. That's what we are learning, right? So move the cursor behind this vector calculus and hit enter. That means this package now is loaded. If you don't load it, it will not actually give you the correct answer. So this is how I just copied the example over here. If you have a vector field, and this is in polar coordinates. So if you look at the first one, is r. R is equal to 0, and theta is equal to 1. So theta is a constant. R is also a constant. And then r goes from 0 to 1, and t goes from 0 to 3 pi 2. So we're going to plot this constant vector inside this rectangle over here, and you will see what we have. Okay, because it's in the Cartesian coordinates, it looks like this. But all these vectors, they are constant vectors in terms of r and theta. Because if you look at r over here, it's always going to be, we know a vector means that you can actually move, right? So theta is fixed, and so we have these vectors in the polar coordinates. It's kind of constant vectors in polar coordinates. They are not constants in x, y coordinates. That's what it means. Okay. So let's look at more familiar kind of vector field when we do have Cartesian coordinates. And this is, I just copied over there. And you can, this is vector field. You don't have to do that. So just put it over here, and then we're going to try to see. Oh, see, these are the vectors, right? Yeah, these are the vectors. Okay. All right, so we do have an exercise for you to do to plot a vector. So you can just copy this one and change things over here. When you enter sign, make sure you sign a pair of parentheses and put an x inside. So these are 3 components of the vector. And you see we exactly use these pointed brackets for vectors, right? And that's what we learned. All right, now let's look at the things we learned earlier. So this is called a multi-integral. That means multivariable integral. And the integrand is x squared plus y squared, and with respect to x and y. And here's the region. This is pretty fine in Maple. Region is a circle centered at 0, 0, and the radius r. And if you integrate this one over here, you'll get some kind of value, right? And then you get a value over here, pi r to the 4th over 2. Okay, so that's the integral over there you have. Now you can try many examples. This is triangle, this is sphere, and here we have parallel bit over here. And again, first one is integrand, and then in brackets you have variables in this order. Let's look at the next one, because this is the one we often do in multivariable calculus. So integrand is x plus y. And if you look at what we have over here, it says x is between 0 and a, and y is between x and x squared. So this is a typical kind of example we have. And we can integrate, and you can see you can even use a variable or a parameter a over there to get the value. If you change it to 1, and then this is what you're going to have. It's a number, right? If you change 1 to 2, you're going to get another number. Okay, so it's going to be another number. Okay. All right, so let's try this multi-int a few more times. And I actually put a problem inside over here. If you look at this one, the integrand is 2x minus y. But we integrate with respect to z first, or z last. See, z is between 0 and 2. Y is between 0 and z squared. We integrate x first, between 0 and y minus z. And you can integrate this one over here. We need to change to colon, semicolon, and then we will see the value, 16 over 15. Okay, so just remember the order over here. Z, that means the last one to integrate. Z between 0 and 2. Y between 0 and z squared. And x is between 0 and y minus z. It's not exactly in the order that we have seen in our textbook. All right, these are the main commands we can use to do multivariable calculus. There are a few more also interesting ones. There is one called Intersect Plot. You can plot intersections of surfaces. And again, you want to input the package first with plots, intersect, plot. And then you see two surfaces over here. The first one is a sphere. The second one, I don't know what it is. I think it's some kind of quadratic surface, because z squared minus z, right? And then you define bounds for x and y, and see this is the box you want to see the picture. Thickness is the line thickness. Orientation, I don't know. So it's direction. If you hit enter, this is what we have. Okay, you can change orientation. Say, I don't like this. So you have to do something. So this is something over there. Okay, so it's the intersection of a sphere and with some nice. Actually, this is not a simple curve because it intersects. Okay, by itself. So let's try. See, we have 70, 140 to see what's going to happen. And enter. It's just from a different perspective. Okay, so it's just different from this perspective. All right, so this is Intersect Plot. And last one over here, I want to show you how you can actually plot parameterized surfaces and also parameterized curves. You just use plot 3D. You see over here, we treat x, y as two parameters. The two parameters in the rectangle. X is between 0 and 2 pi, y is between 0 and pi. And then we have first coordinate x times sine x times cosine y, x times cosine y, cosine x, cosine y. Now I don't see the multiplication sign. Sometimes Maple is pretty picky. So if you want to type in multiplication sign, that's the asterisk you can actually find over there, and then Maple won't actually get confused. It's always better to be complete in Maple, otherwise, especially if we don't know exactly what the surface looks like, and then it's going to be bad. Okay, so hopefully it's going to be fine. So it's going to be some kind of curve. Oh, wow, this looks really nice. It's kind of like seashell, right? Yeah. So try a few examples on your own. We do have some exercises for you to do. The last one you see over here. Now we just have one parameter, t is between -2 and 4 pi. If you remember, this is a helix, sine t, cosine t, t, okay? And it's a helix. There's no color. That's okay. You can try to put the color inside. All right. So have fun to play with Maple and finish the project within 2 weeks. All right. Well, I forgot to show you how you can actually save the pictures and convert these files into PDF. So let me quickly do this over here. So for example, suppose you like one of the pictures. For example, this one, we found this one really nice, this plot 3D over here. So you can actually hit enter over here. So what can you do with the graph? There is a file over here. You can say export. Bitmap is okay. So you can say Windows bitmap because we can easily import that one into many different files. So you save it to your favorite folder or your just folder over there. You can call this one as a seashell. Okay, seashell. Okay, and then you save. Okay, and then what? You can actually open a Microsoft Word document. So let me see where it is. And then you can, I know it's not necessary because you probably much better than I do over here. So over here, you can say this is test graph, test Maple. Okay, and then you get the word, and then here's the insert. Just remember where you saved your picture. So save picture, okay, and I saved in MST 113, right? Math 13. So already actually I have a few of them. So I can just insert this picture over here, right? And then have it over here. You can scale and other things, right? And after that, if you want to turn in and convert it into PDF, just go to File, say Save as Adobe PDF. And then you click Yes. And then you have PDF file over there. Okay, but in order for you to do this, you actually need to install the university software not available at the university website that Adobe Cloud, is that right? And then you have this PDF creator. Now you cannot rotate. Okay, so if you want to have the correct perspective, you need to do it beforehand. Okay, so that's how you can generate a PDF file for your pictures. Now, how about your Maple file? You can also do your Maple file over here. You can also click over here, say print or print preview, and then it's PDF again. You can just print it into PDF, and then you can put them together, and you can turn it in. All right, that's everything.